Come back. Inverse of hyperbolic cosine function, that is cosine hyperbolic inverse of x. Its domain is 1 to infinity, closed 1 to open infinity, 2, closed 0, open infinity. Now here are the steps to identify the inverse of cosine hyperbolic function. Set y, step 1, set y equals cosine hyperbolic x, which is e raised to x plus e raised to negative x by 2. Interchange x and y. You get x equals e raised to y plus e raised to negative y by 2. Now you want to solve for y. Cross multiply. 2x equals e raised to x plus e raised to minus y. 2x is e raised to y plus 1 over e raised to y. Multiply throughout by e raised to y. 2x e raised to y is e raised to 2y plus 1. Get this on here. You have e raised to 2y minus 2x e raised to y plus 1 is 0. Use quadratic formula to solve for e raised to y. E raised to y is your unknown. E raised to y squared. So that's your unknown. Minus b plus minus square root b squared minus 4ac, the whole over 2a. All right, a is 1. So you are using quadratic formula. So that gets you 2x plus minus square root 4x squared minus 4 by 2. So this, notice the 4 comes out common. When it comes out of the square root, it becomes a 2. That 2 and that 2 are cancelled by this 2. You have x plus minus square root x squared minus 1. Now you see, you want a cosine hyperbolic inverse to land from in this set, that is to land at 0 to infinity interval. So I don't want that negative here. You will see in a minute why. So e raised to y equals x plus square root x squared minus 1. Y is natural log of x plus square root x squared minus 1. So if I had taken negative, natural log is defined, but the value would have been negative, overall value. I want the value, overall value, to be positive, non-negative. So that's why we made the choice of a plus in the middle. So cosine hyperbolic inverse function is defined to be natural log x plus square root x squared minus 1. And this is defined for x greater than or equal to 1. Now, derivative of cosine hyperbolic inverse x is derivative of natural log of this expression. Derivative of natural log 1 over the argument times derivative of the argument by chain rule. 1 plus 1 by 2 root x squared minus 1 times derivative of this, that's 2x. Simplify, get common denominator, cancel the numerator and denominator. We are left with 1 by root x squared minus 1. So derivative of cosine hyperbolic inverse x is 1 by root x squared minus 1. Inverse of the hyperbolic tangent function, that is tan hyperbolic inverse x. It's defined over open interval negative 1, 1 all the way to negative infinity, infinity. Here are the steps to identify the inverse. Set y equals tan hyperbolic x, that is sine hyperbolic x by cosine hyperbolic x, that is e raised to x minus e raised to negative x by e raised to x plus e raised to negative x. Step 2, interchange x and y. So x is e raised to y minus e raised to negative y by e raised to y plus e raised to negative y. Now we want to solve for y. Cross multiply. Distribute x e raised to y plus x times x over e raised to y equals e raised to y minus 1 by e raised to y. Clear the denominator, multiply throughout by e raised to y. Multiplying by e raised to y gets me x e raised to 2y plus x equals e raised to 2y minus 1. Combine the e raised to 2y terms together. So x minus 1 e raised to 2y equals negative 1 minus x, that is negative of 1 plus x. Lastly, e raised to 2y is negative 1 plus x over x minus 1. So if I flip this, I get 1 minus x and the negative is taken care of. So notice that negative is taken care of by flipping these two terms. So take natural log of both sides, natural log of e raised to 2y, natural log of the right hand side. So that gets me 2y down. So y is half of all of this. So there you go. You have identified tan hyperbolic inverse of x, that is half natural log of 1 plus x by 1 minus x, and this is defined for x between negative 1 and 1. Okay, so that's important. You don't want x to be less than negative 1. That will make, you don't want x to be, say, negative 2. So negative 2 would make negative 3 here, and no, it's okay. But regardless, my x is between negative 1 and 1 precisely because tan hyperbolic has image negative 1 to 1. Okay, so let's see. Derivative. So derivative of tan hyperbolic inverse of x is 1/2 derivative of natural log of this expression. Now this can be simplified. Natural log of a quotient is difference of the natural logs. Half derivative natural log 1 plus x minus natural log 1 minus x. Half derivative of this 1 by 1 plus x, derivative of this 1 by 1 minus x with a negative from there. Okay, so that overall becomes a plus. Simplify the denominator. So 2, this times this is this. When you look at the numerators, x's get cancelled. I'm left with 2. That cancels the 2. 1 by 1 minus x squared. So derivative of tan hyperbolic inverse x is 1 by 1 minus x squared. So we'll come back in our next video for hyperbolic cosecant inverse and hyperbolic secant inverse. All right, until then, bye.